To begin this section, we're going to be talking about polynomials, particularly how to add, subtract, and multiply. The first thing that we should make note of is that when you're dealing with a polynomial, something like x squared plus 2x minus 3, we say that the degree of the polynomial is the largest exponent. So in the example I just mentioned, x squared, the square is the largest exponent, so the degree would be 2. From here, we say that the leading term, or the lead term, has the degree. So again, in the example I mentioned, x squared would be the lead term. And finally, from there, the leading coefficient is the constant of the leading term. So, in that example, since x squared was the lead term, there's technically a 1 being multiplied to x squared. If there's nothing in front of it, there's a 1. So, the leading coefficient would be that 1. So, let's go ahead and try an example. We want to find out what the degree is, what the lead term is, and what the lead coefficient is. So, in this example, we have x squared minus 5x to the 7th plus 4 minus 12x to the 6th. If we look through this, the largest exponent is that 7. So that means our degree is 7. This is a degree 7 polynomial. From there, the lead term is the term that contains the degree. So the lead term is this entire thing that has that x to the 7th. So negative 5x to the 7th is the lead term. And finally, from there, the lead coefficient is the constant in front of that x value on the lead term. So it's the negative 5. As of right now, we are just making note of what these values are and how to find them. But as we progress through these sections, we will discuss how we can use these values to decide what the general shape of any polynomial graph looks like. They are extremely useful, and we're just bringing them up right now. So from there, we can start talking more about dealing with adding and subtracting polynomials. So we're going to introduce a process that says to add polynomials, we need to combine terms with common variables and exponents by adding the coefficients in front. So what that means is if a term has an x squared, if there's something like a 2x squared minus 3x squared, we can combine these because they both have an x and both of the x's are being raised to the same exponent of 2. So we combine the coefficients in front, the constants, the 2 and the negative 3. 2 minus 3 gives us negative 1, and then we keep the term x squared. Negative 1x squared, which is just simplified down to negative x squared. The same thing is true when we're dealing with subtracting polynomials, except we just need to make note that we need to distribute the negative before we start combining the like terms. From there, everything is the same as adding polynomials. So in this example, we have 2x cubed minus 3xy plus 4 minus the quantity of 2xy minus 3x cubed plus 7. We first need to start with realizing that we are subtracting these two polynomials, so we will distribute this negative to every term. Remember, a term means an entire value that's being multiplied. Once you see subtraction or addition, you're moving on to another term. So everything that's being added or subtracted, we distribute the negative to. In the first case, we can get rid of these parentheses because there's nothing in front of them to distribute. So we end up getting 2x cubed minus 3xy plus 4 minus 2xy plus, because we have a negative times a negative, we switch the sign, plus 3x cubed, and then negative times positive 7 gives us minus 7, and from here we can begin combining our like terms. So we have a 2x cubed and a plus 3x cubed that we can combine together. That gives us 5x cubed. We keep the x cubed, we add the numbers in front. From there we have a negative 3xy minus 2xy. Negative 3 and negative 2 gives us negative 5xy. And the last values, 4 and negative 7, combine together to give us negative 3. There aren't any terms left over. Everything was able to combine with all the other terms. So we have found the simplified form when subtracting these two polynomials. 5x cubed minus 5xy minus 3. All right, so from here, I now want you to take a moment to try to find 5xy cubed plus 4y squared minus 6x plus 2x cubed y, all plus the quantity of 3x minus 4y cubed, minus 4y minus 2xy cubed. Take a moment to pause the video and then we'll try it together. Okay, so from here, we're going to combine our like terms immediately because there's nothing to distribute in front of either parentheses. If there were, for instance, a 2 here, we would distribute the 2 and then start adding them. If this were a minus here, like the last problem, we would distribute the minus. So dealing with this problem, notice we have an xy cubed here and an xy cubed here. We can combine those together, which gives us 5 minus 2 is 3xy cubed. We couldn't combine it with this term because xy cubed is not the same as x cubed y. From there, we have a y squared, but that does not match up with any other term, so we'll just copy it down, plus 4y squared. We have a negative 6x, and that does match up with this plus 3x. So we will combine those terms. Negative 6 plus 3 gives us minus 3, and then we put our x with it. From here, we have 2x cubed y, which doesn't match up with any other term, so we will again copy it down. And finally, we have a minus 4y that does not match up with any other term. We will copy it down, and from here, we have simplified the problem. Sometimes it will work out that the problems will not simplify very much. Notice in this case, we were only able to combine 2 pairs of like terms. All right, so moving on from that problem, the next thing we should note is how to multiply polynomials. So when you are multiplying polynomials, all you have to do is distribute. Everything that's being added or subtracted, every term that's separated by addition or subtraction, I meant to say, you're just going to distribute it. There are other methods for this. One of the most common is the box method. And if you've ever seen that and you're more comfortable with it, then go ahead and just use that. But I found that most people end up preferring this method. We're going to take 3x squared, this polynomial, and distribute it to 5x minus 1, this polynomial. When we distribute it to each term that's being subtracted, 3x squared times 5x, well, 3 times 5 gives us 15. X squared times x, remember when you multiply with the same base, you add the exponents, so 2 plus, there's technically a 1 here, 1 gives us 3. And now we distribute 3x squared to negative 1, which just gives us minus 3x squared. And this is completely multiplied out. Go ahead and take a moment and see if you can't multiply this problem out. 5x plus 7 times 2x squared minus 3x. Alright, so from here, we're going to distribute each value, again, that is being added or subtracted to the other terms. So this 5x will be distributed to the 2x squared and to the negative 3x. We don't distribute it to whatever is inside of its own polynomial, only what it's being multiplied to. So again, the 7 will also be distributed to each of these terms. You may have also seen a FOIL method is one of the most common ways to go about this, but foiling is just another way of saying distribute. So whichever you prefer. So we get 5x times 2x squared gives us 5 times 2 is 10. X times x squared gives us x cubed. And now 5x times negative 3x, 5 times negative 3 gives us negative 15. And x times x gives us x squared. From here we have 7 times 2x squared gives us plus 14x squared. And finally 7 times negative 3x gives us minus 21x. And before we call this problem finished, we're going to check if there's any like terms that will add or subtract. In this case, there are. Negative 15x squared and 14x squared are like terms. We can add them together. So we get 10x cubed. Negative 15 plus 14 gives us minus 1 or minus x squared. Remember, we don't write minus 1 or plus 1x. We always put just minus x squared. We omit the 1. It's not technically simplified to leave it there. And then finally from there we have minus 21x. And this is completely multiplied out. We're going to try one more of these in which we aren't just multiplying two binomials, they're called, when you have two terms in each one. In this case, we're multiplying a binomial by a trinomial. So just like before, we're going to start by distributing the first term to all three terms that are being added or subtracted, and then we will distribute the second term. So 2x times 3x squared gives us 6x cubed. 2 times 3 is 6. X times x squared is x cubed. Then 2x times x gives us plus 2x squared. And finally, 2x times 4 gives us plus 8x. And now we move down to the 1 here. 1 times all of these terms will just repeat exactly what we have. And the trick here is we want to start matching up the terms below their common terms, so it'll be easier to add them. So what I mean by that is 1 times 3x squared, again, will just give us 3x squared. Notice we have a 2x squared here. We are going to write the 3x squared directly below it. Now the 1 times x will give us plus x, which we will write below the 8x. And finally, 1 times 4 will give us 4. There isn't a constant term in the top, so we'll just write plus 4 at the end. And now, when we add, we're just combining our like terms up and down, like you probably learned addition in elementary school. So it makes it easier to deal with this. So 6x cubed plus nothing gives us 6x cubed. 2x squared plus 3x squared gives us 5x squared. 8x plus x gives us plus 9x. And 4 by itself just gives us 4. And that is completely multiplied out. At this point, we just have a few special rules to talk about when we're multiplying polynomials. The first is if we have a plus b quantity squared, then it will always work out that you will get a squared plus 2ab plus b squared. In other words, you will get the first term squared plus 2 times the first term times the second term plus the second term squared. The same thing is true for a minus b quantity squared. You will get the same formula, but with a minus or a negative on your middle term. And finally, this is the most important of the three that I would highly recommend memorizing, whereas the other two, it's useful to memorize, but not as required. This third term is called the difference of squares. If you have some polynomial a plus b, and then the same polynomial but with a negative between them, a minus b, when you multiply it out, you will always get the first term squared, a squared, minus the second term squared, b squared. It is a difference of squares. That's why we call it such. So, let's go ahead and try these out. For the first one, we have 2 minus 3x quantity squared. So, our formula says we take the first term, 2, and square it. We're subtracting, so we put minus 2 times the first term is 2, times the second term is 3x, and then plus the second term squared, 3x squared. And now when we start simplifying this, 2 squared gives us 4. From here, negative 2 times 2 is negative 4, times 3x is negative 12x. And finally, 3x squared. We are distributing the square to each term because we're multiplying. So 3 squared is 9, and then x squared. And before we circle this, just remember that whenever you're dealing with basic polynomials of just one variable, you always want to order by exponent. So we should rewrite this as 9x squared minus 12x plus 4, since that's a positive 4. And this is the multiplied form of 2 minus 3x quantity squared. We could have just done foiling or the distribution method, whichever you're more comfortable with, or the box method. All of them will work, but this is just a quick way to approach these problems. This formula will always work out for problems of this form. All right, finally, I'd like you to take a moment, go ahead and pause the video and try out this last problem. All right, so for this last one, notice we have 5 minus x times 5 plus x. This looks like our difference of squares formula. So we're going to take our first term 5 and square it, and subtract our second term x and square it, which gives us 5 squared is 25 minus x squared. And reordering by exponent, we get negative x squared because we were subtracting x squared. It's negative. And then this is a positive 25, so we have plus 25. And this is the multiplied form of 5 minus x times 5 plus x.